Tell me what's the difference between congruent and similar.
What is the close?
Congruent, same shape, same size. Similar, remember when we talked about similar figures way back when, we talked about dilations, and we said that the angles are congruent, but the sides have to be proportional. Same thing, okay? Same things that we talked about. So let's look at this first one right here. Do you think that they are similar or congruent? Or neither?
Congruent.
Congruent, they're the same size and the same shape?
No, it's like.
Okay, so they're not congruent, they're not the same size. So my question is, in order to be similar, they have to be proportional. So the 2 corresponds with which one? 6. So how do I get from 2 to 6? Times 3. What about 3 times 3? Is that 9? And 4 times 3, is that 12? Okay, they're all the same. That's the same proportion for each one of them. That means that it is similar. Somebody tell me, do you remember what this number right here is called? How much bigger it gets? We can set up a proportion. It starts with an S. We talked about it when we did dilations. Okay, this is scale factor. How do I know? Because right here, is my shape getting bigger or smaller? Bigger. What kind of number would this have to be in order to make it smaller?
It'd have to be
Less than 1.
Not negative, less than 1. It had to be a fraction. And the fraction would have to be less than 1. So if my scale factor is less than 1, then it's a reduction. And if my scale factor is greater than 1, then it's an enlargement. Okay, next one. Similar, congruent, or neither? Are they the same shape?
Yes.
Are they the same size?
Yes.
This triangle's 5, 5, and 5, right? This is 5, 5, and 5, correct? And then the height is 7 and 7, so this is absolutely congruent. What about this other shape over here? Similar, congruent, or neither?
Neither.
But wait a minute, this is 12, and this one's 12. Aren't they the same?
No, the radius is different.
Good, the radiuses are different, correct? So if I use this side, it's 12 over 12, which is a scale factor of 1. And if I did the radius, it's 8 over 4. That gives me a scale factor of 2. These two numbers must be the same in order for them to be similar. Okay, which is why this one is neither. Okay, I'm going to give you just a couple of minutes, and I want you to do 1 through 6. Determining whether they're similar, congruent, or neither. Be careful, because there's some things you need to do. All right, so on number 1, what do you think? How many of you think it's similar? Raise your hand. How many of you think it's congruent? And how many of you think it's neither? So the first question is, are they the same shape?
Yep.
They're both cones, right? This one says that this line is 30. What's that line?
15.
Diameter.
Oh.
This line right here is 15. What is that? A radius. So how big is the diameter going to be?
30.
Oh, you mean the same as the other one? Here they tell me that this one is 20. That's the height. Here they tell me the slant height is 25. Can I compare the 20 and the 25? No. But what I could do is figure out what this height is now that I have two sides here. X squared plus 15 squared equals 25 squared, which would absolutely make this one 20. So these two are congruent. You may have to find missing pieces. All year long we've talked about ways of finding pieces if you don't have them, correct? Okay. Next one. How many of you think they're similar? Raise your hand. Congruent? Neither. Okay? So this is 1 and this is 4. So 1 over 4. This is 5. This is 12. Can I reduce that down? In other words, here from 1 to 4, isn't that times 4? That means it would have to be 5 times 4. Is that 12? That's no, so that one is neither. Number 3, how many of you think it's similar? Congruent? neither. Okay, it is absolutely congruent. The big part of the L is 6 on both of them. The top of the L is a 2. The height is a 7, right? And then we have this other little 2 here, so it is absolutely
So on these,
congruent.
you're basically just counting up the sides.
You're just looking to see are they the same or not. If all the sides are the same, then they're going to be congruent, as long as they're the same shape.
So the next one will be similar.
Number 4 would be similar. Well, we know they're not congruent because the numbers aren't the same, correct? Okay, let me remind you, we've talked about this before when we did similar figures. Anytime you have a circle, which now includes a sphere, those will be similar if they're not congruent. So there is no guess because there's only one dimension in a sphere, and that's the radius. The radius is the same in all directions, right? So if I change one, I have to change them all. So number 4, that sphere is definitely similar. Number 5, how many of you think that they are similar? How many of you think they are congruent? How many of you think that it is neither? First question is, are they the same shape?
No.
No. This one's a cone, this one is a cylinder, that means that is neither, period. They're not the same shape. Congruent, same shape, same size. Similar, they have to be proportional, but they need to be the same shape. So we're not comparing the same things here. And then number 6, how many of you think they're similar? Congruent? Neither. Okay, here, how do I get from 2 to 6?
3.
Times 3, how do I get from 7 to 21?
3.
So these are absolutely similar because their scale factor is the same. Is my shape getting bigger or smaller? Smaller, so is my scale factor really 3?
No.
No, my scale factor is really 1 over 3. Okay? Stop. Okay, on the back side, let's talk a little bit going back to what we did a couple of units ago. Okay, there's a such thing as a ratio. And back then we talked about perimeter and area. Now what I really want us to do is to jump to volume. Okay? So it's saying right here, find the surface area and the volume. Before I do that, I want to talk about their ratios. That's like what we just did on that first page. Right here, if this side is 1, it's compared to this side, which is 2. Is my shape getting bigger or smaller? Bigger. So what would my ratio be? 2 over 1, right? 2 over 1. Would it be true? It's 2 times bigger? Okay. What do we know about area? Area is always squared. Very good. And volume is always cubed. The good news is, remember, just like before, if this is my perimeter, then how do I get to my area? Well, if my perimeter is 2 over 1, to get to my area, don't I square it? What's 2 times 2? What's 1 times 1? 1. So my new ratio would be 4 to 1, because my shape is going to get 4 times bigger. Remember I was talking about that before? And then you said that my volume is cubed, so I'm going to use my perimeter ratio, and now I'm going to cube it. What that means is 2 times 2 times 2. Well, what's 2 times 2?
4.
4 times 2 is 8. And then down here is 1 times 1 times 1, which is 1. So my volume is going to change by 8 times bigger, because it's cubed. Okay, so if you're going to Ramsey, you have no idea what you're talking about. Well, good. Let me show you. Let's do the surface area. I'll explain it. So if I did surface area of this shape, it's perimeter of the base times the height, plus 2 times area of the base. So if I'm looking at this shape, it's 2, 5, 2, 5, which is 14. That's the perimeter of my base. And then my height is going to be 1, correct? So that's 14. Area of my base, that'd be 2 times 5, which is 10. That would give me 20. That means that the surface area of my shape is 34 centimeters, was it centimeters? Yeah, centimeters squared. If I want to know what happens when I double it, what will be my new surface area? I don't have to go and rework it. I can just say it's going to be 4 times bigger because we're talking about area, and that magic number is going to be times 4. So 34 times 4 is 136. So my new shape, my big one, should be 136 centimeters squared. Well, Ms. Ramsey, I'm not sure that that's true. Let's try it. So let's do the same formula. Perimeter times height plus 2 big B, right? So the perimeter of my base is 4 and 10. That gives me 28. And then my height is going to be 2. 28 times 2 is what, 56? And then the area of my base is 10 times 4. So it's 10 times 4 is what, 40? Times 2 gives me 80. When I add those up, don't I still get 136 centimeters squared? So did I really have to work this out? No, not if I know whatever my ratio is, I square it, and that's going to become my new magic number for the change. Okay, well, Ms. Ramsey, does it really still work for volume? Well, let's go back and find volume real quick. Okay, so if I'm going to do volume of my small one, isn't that area of the base times the height? So it's 2 times 1 times 5. That would give me a 10. 10 centimeters cubed. Without telling me that my volume is going to change by 8. That means the volume of my large figure is going to be 80 centimeters cubed. Is that true? Well, let's check it. Let's go back and rework it using the large one. Volume equals area of the base times the height. That'd be 10 times 4 times 2. 10 times 4 is 40. Times 2 gives me 80 centimeters cubed. Are we okay there? And the reason I know that is because I take whatever my ratio or my scale factor is, and we cubed it. And that will tell you how much your volume changes.
Why your bottom number don't change?
One more time.
Why your bottom number don't change?
What do you mean, this number?
That 1, the 2 over 1.
The 2 over 1, it doesn't change because there's just one measurement. And if I double it, it's going to get twice as big. But if I do area, I have a length and a width. So if I double this one, then not only is that going to change, but it's going to change twice to keep it the same shape. Okay? Now, here's what I want you to do. I'm going to give you just a couple of minutes. I want you to work, this is all one problem right here, 5 through 8. All deals with the same thing altogether. So I'm going to give you just a couple of minutes, and I want you to try and come up with those answers. If you finish before I'm back, then try 9 and 10. Before now you're doing... All right, so I want to go do the scale factor for this one, but this one was different than the other one that we had done, right? Are we good? Because before on the other one, I just figured out which number did I need to multiply to get to the next one. But when I'm looking at this, how do I get from 9 to 6? How do I get from 15 over 10? There's not really a number to multiply. So set them up as a ratio. So this is 9 over 6, or is it? Question, can it really be 9 over 6? Why not? What's my shape doing? It's getting what? Smaller, right? 9 over 6 is a number over 1, so that can't be. So I would have to flip it to be 6 over 9. Can I reduce 6 over 9? To what?
2 over 3.
2 over 3, right? Well, let me see, the other side is 15 and 10, so that would be 10 over 15. Does that reduce down to 2/3? And then the other one would be 8 over 12. Does that reduce down to 2/3? So that means that my ratio or my scale factor is 2/3. The next question says, well, what would we do if it was the surface area? What do we do if we're talking about area? We square it. So I want the ratio, so it's 2/3, but I need to square that. That means 2 times 2, which is 4. And that means 3 times 3, which is 9. So my new ratio for my surface areas would be 4 over 9. Now they want us to do the same thing for the ratio of the volumes. That means I'm going to start with my regular ratio, which is 2/3, but when I talk about volume, what do I need to do to it? Cubed it. So that means 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8. And then down on the bottom, 3 times 3 is 9 times 3 is 27. So my new ratio for volume would be 8 over 27. Okay? On number 8, it says the volume of the large prism is 810 cubic centimeters, right, volume. Find the volume of the smaller one. So let's just do large over small. The large one is 810. The small one is going to be X. That's what we're looking for. Because we're talking about volume, that means I want to use this ratio right here. Which one's bigger, 8 or 27?
7.
So that means that 27 has to go on top, and 8 has to go on the bottom, and then we're going to cross multiply. So that would give me 27x. Somebody multiply 810 times 8, and tell me what do you get?
6,480.
6,480. Now what? Divide by 27, and you get 240 centimeters cubed. So this right here would be my small prism. Okay, I want to give you a couple minutes to do 9 and 10.
We don't have a
Put a little one.
8,100.
All right, so it says that we have a model and we have a house. Okay, the model is 1 over 100. Stop packing up. It says that the house is 84 inches. How big is the model? Again, we're going to cross multiply. That's 100x is equal to 84. Divide by 100. So that means that my answer is 8.4 inches. That would be how big the model is. Okay?
Area or,
No, it's just tall. It's just one length, inches. On the next one, they have a model and they have a building. Right? It says that we have 1 inch for every 15 inches. And then it says the scale model is 3,456 square inches. What does that mean? What are we talking about there? Area. That means I need to square this. So this is actually going to become 1 over 225. The model is 3,456. We're looking for the building. Oopsie. Okay, here I'm going to cross multiply. So X is 777,600. And then the next question says, I don't want inches because this is going to be inches squared. I want feet. So if I came down here, 7,000 inches squared, how many inches are in a foot?
12.
Right? But I don't want 1 foot and 12 inches because I need it to be squared. So I will have to square this. So it'd be 1 over 144. So 777,600 divided by 144 is what? Somebody push buttons. What?
5,400.
And that would be feet squared. Have a good day.